I'm going to give a quick overview of our simulation. My name is Jason Reeder, and I worked with Jared Allen, and we did a game of life simulation. I'll go ahead and start the simulation. Over here on the left side, we have our user inputs. Here in the middle, we have the game board where the simulation actually takes place, all of the births and the deaths. And then here to the right, we have a zoom feature where you can make the board larger or smaller. And then we have some output over here for the population, the births, and the deaths. All right, now I'm going to talk about how we actually load the board and get it to run some simulations. So we looked up a lot of interesting shapes on the internet that people have already found that do useful or cool looking things, and we've put them in this drop down list. I'll go ahead and pick the Gosper glider gun, and then we click place, and you see the Gosper glider gun gets placed on the board here. Now we can run the simulation, clicking play, and as you can see, the Gosper glider gun begins and it starts shooting off little gliders. Alright, now we can pause this, clear the board, and we also have another way to load the board with random values. And there's a twist to this because once we place the random values, we've actually added color to the simulation. So the normal game of life rules is that if three neighboring cells are alive, then that cell becomes alive. In our simulation, the rules are also true, but now there's a color component added that is the average of the red, green, and blue values of the three cells that are birthing the new cell. So we can go ahead and create a random board that's pretty dense so we can make sure to have some births, and then we can run that. And as you can see, the colors slowly come together and create new cells that kind of blend and merge in the end. I'm going to continue to talk about board initialization. We're going to load a board from an image this time. I've got a couple images here you guys might recognize. As you can see, when we first load the image, it's fairly dense here in the middle, and using the normal game of life rules, all of these cells would die from overpopulation. So we added a threshold so that when we convert it to grayscale, this threshold determines whether or not the cell is alive or dead. So we can move that threshold over to make sure that mass number of cells don't die in the beginning of the simulation. And then we can also change the pixel color just for aesthetic values in this situation. And then we can click OK and add that to the board. And as you can see, our zoom level was changed from 1000 down to the zoom level of the image that we imported. So we'll go ahead and slow this one down so you can see it working, and we'll play that one. And as you can see, usually in the beginning from an image, it's kind of like edge detection. The edges stay because the other ones kind of die from overpopulation. And go ahead and stop that one and clear the board, and we'll load one more image to show you. This is the image from the class website, and we can kind of turn the threshold all the way up on this one. We'll leave this one as black, and we'll go ahead and run that simulation. I'm going to talk about the playback controls of our game of life simulation now. I'll go ahead and place an interesting shape. That's the lightweight spaceship. Playback controls are play, pause, forward. It's a single step forward. And we also have a single step backwards, which is kind of rare in game of life simulations. I'll go ahead and let that run for a while. As you can see, the lightweight spaceship just goes from left to right. And I'm going to pause it. We can actually step backwards in our simulation. Go ahead and let it play again. And with our playback controls, we can control the speed also. You can speed it up, or you can slow it way down to where it takes a long time for even a single step. Now I'm going to talk about the record video function that we added to our simulation. I'm going to place the acorn shape here on the board, and I'm going to start recording, and then I'm going to hit play. And as this plays the simulation, our game is actually recording the output. So I'm going to go ahead and pause that and tell it to stop recording. It asks us where we want to save it. Just give it a name and hit OK. And once we've saved it, our simulation actually knows where the file was saved, so we can go ahead and open it right from our simulation. And as you can see, there's our simulation that we just ran. And that is stored as an AVI file.
All right, this is Jared Allen. I worked with Jason Reeder on this project, and I'm going to be showing you some of the outputs of our simulation, some things we can do in addition to just drawing the game board. So first thing I'm going to do is place an acorn shape and then allow us to step through the simulation. And so you can see on the right we're actually tracking some statistics of the simulation as it goes. On the first graph we have a graph of time that shows the actual population of our simulation. So you'll see we initially start out with a population of 0, and then when we place the acorn and allow it to give birth to other cells, you can see our population rises over time, and then it starts to drop as overcrowding occurs. On the second graph, we actually show the number of bursts that occur in each step, so you can actually see the pattern over time, that it initially gave some bursts, and then it dropped, and then it went up to actually a maximum of 12 births. On the last graph, we also show the number of deaths, so the number of cells that actually died due to overcrowding at each time step. So next we can actually show how the music actually plays throughout the simulation. So we've placed our shape, and we're just going to hit play, and you'll see that we have the instrument selected, so it's going to play a different piano note on each iteration. And you'll see we can actually speed up the simulation and tell the instrument to play, and it'll actually play at that faster rate. Although the music may sound a little chaotic, all of the notes are governed by the actual rules of the simulation, so it's possible for us to actually clear the board, place that acorn, and continue to play, and we'll actually get that same sequence of notes that we had earlier. So you'll see here that we can actually change the instrument, and so we'll choose a percussion this time, the melodic toms, and when we actually play back, instead of playing piano notes, we'll play a different drum in our set. So the last thing we wanted to show is the actual code that runs the simulation. So if we go to here, we can show the block diagram and show you that this whole simulation was created inside the LabVIEW programming environment, which follows a data flow paradigm. We decided to use a combination state machine and event structure. So you can see we have this event structure that controls all of our button clicks and events that are initiated by the user. So if we click on this drop down, you can see all of the different states that are part of our simulation. One that would probably be of note is the actual game of life iteration event, which is fired every time we execute a certain iteration of our simulation. And so the execution occurs from left to right and follows the actual flow of data. And so we keep track of all of that data inside of shift registers, and we also keep track of any errors that might occur so that we can handle those appropriately or shut down the simulation in case of an error.